So we'll do another one like this, like example 4. Solve for theta. Cosecant of theta is equal to negative 5/3. So because we have cosecant and we know that cosecant of theta is related to sine, I would be able to write that sine of theta is negative 3/5. And from this, I can tell from my cast rule that it's not in quadrant 1 and quadrant 2 because sine is negative. Now, as you get further along in grade 12, you won't always have to draw these pictures because you will just have these pictures in your head, but early on, it's really important for understanding to have a visual. So if I have an angle in quadrant 3 or in quadrant 4, I can draw that angle, and when I draw that angle, I can make a triangle and label the reference angle. Now, if sine is opposite over hypotenuse, I would be able to tell you that this length is 3 and this length is 5. Same thing on this triangle. This length is 3 and this length is 5. Now that I have that, I can go to grade 10 trigonometry and find my reference angle. So one of the biggest issues that students have in trigonometry is they try to do too much too fast. So a lot of students will see sine theta equals negative 3/5, and they'll go right away to sine inverse of negative 3/5. And that causes them problems because they need to solve their reference angle in order to find both of these. So taking a step back, we now solve for our reference angle, and this is a good example. When you're solving for a reference angle, even though the original question had negative 3/5, when you're solving for your reference angle, it's always based on an actual triangle and actual lengths. And if I draw a triangle, I can't have a length of negative 3. The length is 3. The hypotenuse length is 5. When we're talking about actual lengths on a triangle, we're always doing positive values. So solving for reference angles always involve only positive values. So I have sine of my reference angle be 3/5. I can now go to my calculator and find my reference angle by doing sine inverse of 3/5. And I get 36.9 degrees, round to the nearest degree, 37 degrees. So I now know that that reference angle is 37 degrees. I'm only looking from 0 to 360, so I'm only looking in the positive direction. I'll draw them in green in standard position. That's starting from here. This would be one answer, and this would be the other answer. Can you see in this one, in order to find out what this angle is in standard position, we could go all the way here, which is 180 degrees, but then we would have to add our reference angle to that. The diagram really lets you see what this angle needs to be. I almost would like to say common sense, that this is like 180, and the reference angle is 37, we have to add 37 more. When you see the picture, it makes sense, right? I much rather you look at the picture and have it make sense. There are some students who memorize, oh, in quadrant 3 is 180 degrees plus the reference angle. I don't think that's worth memorizing, because if you draw the picture, it just makes sense. And if you try just to memorize something without it making sense, guaranteed, you're going to make some errors. And if something makes sense, why waste your memory? Because you're going to have a lot of things that you're going to need to remember in this course and other courses. And your memory is good, but you know when you try to memorize too much, you start forgetting a few things. So whenever we can have things that make sense, that's going to help. So now I do 180 plus 37, I get 217 degrees. And same thing in quadrant 4. If I think about this logically, well, how would I figure out what this angle is? Well, if this was 10 degrees, this angle would be 350. If this was 20, this would be 340. What am I doing? I'm saying, well, all the way around is 360. So if I just subtract this part, I'm going to be left with the actual angle. 360 minus 37 degrees. 323 degrees. Again, these questions are sort of the fundamental trig questions that we're doing, and they're built on trigonometry since grade 10. In grade 10, you only did triangles. So that's why we draw the diagram, because you're connecting your reference angle solving part. That's grade 10 trigonometry. Grade 11 is where you added the cast rule. So in grade 11, that's where you realized, oh, it could be in quadrant 3 and quadrant 4. And now in grade 12, we add reciprocal functions. So now we have an extra step where we go, oh, since I had cosecant, I can change that to sine. And as soon as I've changed it to sine, now we're back at a grade 11 question, which we have to do all this stuff. So it really is building from your previous years, okay? And sometimes you haven't done grade 11 for a while, so we've forgotten some of this stuff. So we review it, think about it again, and build on that.